So section 3.6 continued. What we were doing in section 3.6 is we were asking the questions, when is a graph above or below the x-axis? And if you were dealing with a polynomial, then what happened was anywhere you had an x-intercept, the graph could change which side it's on, but it didn't necessarily have to. So with a polynomial, if graph crosses at an x-intercept, then it changes whether it is above or below the x-axis. And what I did last time is, because to avoid always having to draw a graph, what I did was I showed you how to make a number line that just represented when a graph was above or below the x-axis. And the number line was not meant to be a mystery. It was not meant to be a brand new thing. It was just a way of avoiding drawing the whole graph, and you could represent where a function was above or below the x-axis on a number line instead. So the pluses meant we were above. I did line this up on purpose so it lined up with those. You could decide whether the graph was above or below by looking at the number line rather than looking at the entire graph. And there will be one of these on the test where you're given a polynomial inequality. And you have to write interval notation whether or not it's above or below. But you will not be given the graph, you'll be given an equation. So that was one type of problem we looked at last time. The other type we looked at, and we were looking at the very end of class, was maybe a rational function. And what was interesting about a rational function was a rational function can change what side of x-axis it is on at an x-intercept or a vertical asymptote. Because what you'll notice is this thing goes from being above to below to above. But at one place it changes from being above to below at a vertical asymptote, and it changes from being below to above at an x-intercept. So we're going to try a couple more of these kind today, because I know we did it very quickly at the end of class last time. And we're going to make sure we understand how this works, deciding when a rational function is above or below the x-axis. But the number line, as I said, was not meant to spook you out. It was not meant to make you feel like it was a whole brand new concept. It was just another way of representing whether the graph was above the x-axis or below the x-axis. That was all it was for. All right, so everyone feel caught up with where we were last time? Any questions, comments, concerns? Let's try an example. Okay, so let's do when is x minus 10, and we'll do x plus 4, and we'll go ahead and do less than or equal, actually we'll do greater than or equal to 0. Greater than or equal to 0. So, what are we going to do? We need to figure out where this graph has a vertical asymptote or where it has an x-intercept. Can anyone tell me where this graph has an x-intercept at what x value? 10, the value that makes the top equal to 0, 10, 0. 10, 0, yes. And it has a vertical asymptote at the exact same x value that you would kick out of the domain. So what x value do you kick out of the domain? -4. So when we make our number line for this one, and I mark on it 10, and I mark on it -4, it is a good idea for me to note to myself that -4 is a place where we might switch from above to below or below to above, because it's a vertical asymptote. And 10 is an x-intercept. Then it's just a matter of picking sample numbers. Now be careful when you're picking your sample numbers, everyone, because when I don't give you the number line and you have to draw it yourself, it's very, very easy to mess up a number less than -4. When I ask for a number less than -4, a lot of people think -3. But that isn't right. What's less than -4, everyone? -5. But you'd be amazed how easy it is to make that mistake when you're in a testing situation. What's a number that's between -4 and 10? 0, that will work. And what's a number bigger than 10?
11.
11, good. I'm going to take each one of these. I'm going to plug them into the function. There's not that many of them, so it's like kind of finding like 3 ordered pairs. And once again, you really don't care what the number is you're getting. All you care about really is if it's positive or negative. So for this first one here, I'm going to get -15 over -1. Is that positive or negative? That's positive. Negative over negative. -10 over 4. A negative over a positive is negative. And this is going to be, looks like 1 over 15, which is positive. All right. Now, we write down our intervals for where this graph is either above or touching the x-axis. And hopefully you remember the part about this that's a little bit tricky from last time. Because there's like very sneaky about this with the brackets and the parentheses. If you remember that from last time, you're in pretty good shape. So let's go ahead and write down our answer. When are we above or touching? In just a moment here, I'm going to be asking for some help finishing up my answer because I'm not quite sure what to do. Because that says equal to 0, greater than or equal to 0. So do I need 2 brackets?
Yes.
Yeah.
Yeah.
I see some people shaking their heads no with a lot of confidence. Can someone who's shaking their head no tell me why I don't need 2 brackets? Yeah, go ahead.
Is it because the vertical asymptote is -4 and you never touch the vertical asymptote?
You never actually touch at the vertical asymptote. You touch at an x-intercept. But if you have a vertical asymptote, everyone, and see if this sounds familiar from last time, this is why we're doing this problem. If you have a vertical asymptote, it always gets a parenthesis. This one gets a bracket because it's an x-intercept. And that's actually a place we touch the x-axis where we don't actually touch it at the vertical asymptote, we just switch which side we're on. Well done. Now does that sound familiar to everyone and why we do that? Because we don't actually touch. The equal to, when you write equal to here, you're saying this thing is equal to 0 at that number. But if you put a -4 in here, it's undefined. It's not equal to 0. So remember, let me try it like this. Let's see if this helps. Because I want to make this very clear and make sure everyone's on board. So if you put a -4 in there, it's undefined. It's not equal to 0, so no bracket. But if you put a 10 in there, you get 0. So you get a bracket. Does that help? So never, ever, ever use a bracket at a vertical asymptote. All right. Questions, comments on that problem?
So, hold it, that's it, that's the extent of that problem.
Yep. Well, that's the explanation. Let me circle the answer for you. There's one like this on the test. The answer we were looking for was just this part right here. But the reason I was doing this one was to remind us that we only use parentheses and vertical asymptotes, and we only use a bracket and x-intercept if it has an equal to. You see, when you're doing the polynomials, when you see that equal to, you just assume you're going to have brackets on everything. And that works for polynomials, because for polynomials, they're all x-intercepts. But in the case of a rational function, since we might have a number on the number line because it's a vertical asymptote, that gets a parenthesis. And the reason for that is, everyone, is because we are trying to say, with our brackets, that it equals 0 at that number. But this function, x minus 10 over x plus 4, does not equal 0 at negative 4. It is undefined at negative 4. Not equal to 0. Okay. All right, now the next thing I'm going to show you is not on the test, but will help with homework. So this you do not need to study for the test, this next example, but you might want to keep this page near you when you're finishing up your 3.6 homework, because you will see a problem like this in the homework. And that is, everyone, the frustration of when there's not a 0 on the other side. Because whether or not we're doing these with polynomials or rational functions, we need this to be 0. We cannot do this if this is not a 0 over here. So here's what we're going to have to do. I'm going to try and do this as many steps as possible so I don't lose you. I'm going to subtract the 7 from both sides. Now I have a 0 over there. But this is not that easy to work with like this. So what I need to do is I need to combine the 14 over 3 plus 2x and the minus 7. I need to combine them together. And the way I combine them together is I need a common denominator. So if you think of it like this, everyone, we've got 14 over 3 plus 2x minus 7 over 1. And so I need a denominator of 3 plus 2x on this one also. So here's what I do, everyone. As I said, I'm trying to show you every step on this, even though some of you might not need every step, because I want everyone to get this. I multiply that fraction by 3 plus 2x over 3 plus 2x. And now, I have 21 plus 14x all over 3 plus 2x. Now because I'm subtracting, this minus sign right here has to distribute to both terms in the numerator. So this is going to end up being this, 14 minus 21 minus 14x all over 3 plus 2x is less than or equal to 0. Is this on your test, everyone?
No.
No. Might you have to do one like this in the homework, though?
Yes.
Yes. Yeah, I wouldn't teach it to you 2 days before the test. That'd just be dirty. So we get negative 7 minus 14x over 3 plus 2x is less than or equal to 0. That's it. Now, it might not look like your favorite problem, but it looks more like the ones we're used to doing because we have a 0 on the other side. And now, once again, the two questions we ask ourselves is when is the top equal to 0, because that will give me my x-intercepts, and when is the bottom equal to 0, because that will give me my vertical asymptote. And there's no shame at all in doing a little bit of work off to the side, everyone. I don't expect everyone to just glance at that and get this right. You are allowed to come down here and do a little side work and figure out what makes the top equal to 0. Well, if I add 7 to both sides and divide both sides by negative 14, I get negative 1/2. Never let anyone give you any crap about showing your work. Set the bottom equal to 0. 3 plus 2x equals 0. Subtract 3 from both sides. Divide both sides by 2. And I get x equals negative 3/2. Yep, that happens. We get fractions every now and then. We can deal with that. That's okay. Which of those fractions is smaller? Negative 3/2 or negative 1/2? Which one's smaller? Negative 3/2 is smaller. So there's negative 3/2, and there's negative 1/2. This right here is an x-intercept. This right here is a vertical asymptote. Now, just because these are fractions doesn't mean your sample test numbers need to be fractions. I need something that's less than negative 3/2. You don't need the closest number to negative 3/2. You don't need a fraction. If you want to, just watch this. You can do this. Negative 10. Will that work? Mm-hmm. Yeah. There is one good number to pick between negative 3/2 and negative 1/2. What is that? Negative 1. It's the easiest number to pick in between those. And what's an easy number to pick that's bigger than negative 1/2? 0, 10, 1. Go with 0. I like 0. Now, what do we do with those 3 sample numbers? We plug them back into this one, our modified one, to see if we get something positive or negative. All right, so if I plug negative 10 in there, I mean, look at this, everyone. It looks like I'm going to have a positive number on top, because this is going to end up being 140 minus 7. That's going to be positive on top. The bottom, I'm going to have 3 minus 20. That's going to be negative. So if I get a positive over a negative, what's that going to be? It's going to be negative. Can we assume it just switches at both of these? You could try that, but I would finish it up by doing your math, especially in the testing. I mean, this is not a test, but you know, you don't want to try and make shortcuts if you have time to do it the right way. This time I'm going to get a positive on top and a positive on the bottom. And the reason I like to pick 0 is because now I'm just going to have negative 7 over 3, which is clearly negative. And I got my number line. I don't want to draw this whole graph. It sounds like a pain in the neck to draw it. With a vertical asymptote, negative 3/2, and x-intercept, negative 1/2, that sounds annoying. I don't need to draw the whole graph, though, because I know where the graph is above and below the x-axis. Below, above, below. This has an equal to on it. Everyone write the answer. I know I'm looking for the minuses. Which one of those gets a parenthesis? Negative 3/2 or negative 1/2? Negative 3/2 because it's the vertical asymptote. That's okay. Morning math. And negative 1/2 gets a bracket because it's the x-intercept. And we're done. This is not my favorite thing to do. And the reason I don't put this on an exam, 2 reasons. One is because it really doesn't test you on the concept we're learning. It more tests you if you can do a bunch of nasty algebra. And the other one is because it's unfair to teach you something 2 days before the exam and then say, do that. Memorize that in 2 days. But do keep that page of notes near you when you're doing your homework, and I think it will help you out a lot. And we're going to call 3.6 done. And we're going to talk about the test a little bit. I have a couple things I want to show you before we take the, I don't want that right now. I want to show you this thing. Copy. It's been a long time since we've done this, so I just want to remind you of a couple things. I call this part of the lecture Finding Quick Zeros. When someone tells you to find the zeros, I'm saying like x squared minus 12. Can you see that in the back okay? Can you see that okay? When someone gives you something like f of x equals x squared minus 25 and you're told to find the zeros, it is very, very easy and lazy to just glance at it and say 5. Because if I plug a 5 in there, I'll get 0. But really what you need to do with that, if I ask you to find the zeros, is you need to set it equal to 0 and factor it as a difference of squares, and then identify the two zeros from the two factors. That's one way you can do that. The other way you can do that problem, that exact same problem, no difference, is because it just has the x squared in the number, after you set it equal to 0, you can add the 25 to both sides, apply the square root property, and get negative 5 and 5. Neither one of these is preferred over the other. They're both equally good. So if I gave you this problem on a test, then I don't care which one of these techniques you use, but don't just guess 5. Because that's only one of them. You got to find them both. While imaginary numbers can turn into factors, generally, if you have something like x squared plus 25, you don't try to factor that one. It does factor to x plus 5i and x minus 5i, but most people don't do that. What they would do is they'd set it equal to 0, subtract 25 to both sides, apply the square root property, and remember, when you see something like the square root of negative 25, that's exactly the same thing as the square root of 25 times I on the outside. You can pull out that negative and just put an I on the outside. Then the square root of 25 is just 5. And since we applied the square root property, this one has a plus minus. And that's how you get the two answers there. Now, I'm not saying you don't know that. I'm not saying I can't believe you don't know that. I am saying we haven't done that in a while. That was like one of the first things we did. And so this is not a reminder only about this, but it's a reminder to go back maybe and look at day 1 of the notes. Don't just assume, since we did it so long ago, that you got it. Go back and look at your earlier notes and make sure you got all those old things we did. All right. Next big thing I prepared here is this one. Yeah, we'll do this one. I want you all to remember that we looked at quadratics in two basic forms. One form was the form ax squared plus bx plus c, and the other one was a times x minus h squared plus k. There were two different forms. And the big difference between these two forms as far as doing your work was how you found the vertex and how you found the y-intercept. When you have it in this form, the ax squared plus bx plus c form, that's when you have to use your negative b over 2a formula. You got to use that, and remember that only gives you the x value. And once you get that x value, you got to run it back through the function to get your y value and get your answer of an ordered pair for your vertex. The payoff for the fact that it's difficult to find the vertex is it's very quick to find a y-intercept. Because if you plug a 0 into this, everything goes away except for what? The 15. And that's exactly how you get your y-intercept. So make sure you know how to find the vertex and the y-intercept when your function is given in this form right here. We'll practice some other stuff with quadratics in the practice test today. Remember, if it's given in this form, this a times x minus h squared plus k form, the good news is it's fast to find the vertex. Because the vertex is just right there in front of you. But what you need to remember to do is switch the sign on x. And then you got it. So it becomes negative 316. The y-intercept, though, many people make the mistake of thinking the y-intercept is always just the number at the end. But with this one right here, if you plug a 0 into it, find a y-intercept, you actually have to do some number crunching here, which I've outlined here, and I'll, of course, post this after class with all the other notes, and it actually ends up being negative 2. So the y-intercept is a little bit more difficult to find when it's in this form. So make sure you spend some time familiarizing yourself with the different forms of the quadratic, because quadratics were a pretty big part of what we did in this unit. And we kind of learned these two basic forms, and you need to know how to work with either form. Any questions or comments on that? Finally, and I know you're not going to try and feverishly copy this all down right now, because it's quite a bit of information here, but I want this to be in your notes, and we'll talk about it a little bit. Is I just want to go over the rational function instructions real quick again before we take our pretest. So this is pretty much everything but graphic. So the first thing I want to remind you is when you're giving your domain, it must be given an interval notation. You have to remove all the values that cause division by 0. May need to factor denominator. In order to do this, it might be the case that you need to factor your denominator. So if you're having trouble factoring some basic quadratics, and I'm not talking about like these quadratics where like, you know, the kind we complete the square on or use the quadratic formula on. I'm talking about maybe things that look like this. X squared minus 2x minus 8, which factors as x minus 4, x plus 2. I'm talking about factoring things like that. You do need to be able to factor ones like that on the test. Or maybe something like this. X squared minus 6x plus 9 factors as x minus 3, x minus 3.
What's the highest degree that you'll give us for a factoring problem?
For this kind of factoring problem would be a quadratic. I mean, for something where I intend for you to do synthetic division in the problem, that would be a higher one.
How high?
I don't know, 4 or 5. Yeah, I'm talking about, right now I'm talking about just like doing some quick factoring on a rational function where the whole point of the problem isn't factoring. Some of those problems we did with synthetic division, the whole exercise was factoring a large quadratic. That was the goal. This is just one part of this problem, so I'm not going to give you like a 4th degree in the denominator of one of these to factor. Okay. Once you have kicked numbers out of your domain, they are turned into vertical asymptotes right away. And what I did here, everyone, is I wanted to show you some bad notation. Remember, vertical asymptotes are not just numbers. They're not y equals a number, and they're not VA equals a number. They are x equals the number. So please make sure that every time you give a vertical asymptote, you're writing it as x equals a number, not one of these bad forms down here. Just the number, or writing y equals is for horizontal, or writing VA equals. It is possible for a domain to be negative infinity to infinity, and that would mean that there are no vertical asymptotes. Horizontal asymptotes are always found by analyzing the degree of both the numerator and the denominator of the rational function. If the degree on the bottom is larger, the horizontal asymptote is y equals 0. Not just 0, not x equals 0, not HA equals 0. And even though it's right on the x-axis, you don't say the x-axis, you say the equation. You say y equals 0. That's where it is. And if someone said, yes, Steve, it's right on the x-axis, I'd say yes, but the problem says give the equation of the vertical asymptote, not the location of the vertical asymptote. So we do use the equation. If the degrees match, the horizontal asymptote is found by doing the leading coefficient of the numerator dividing by the leading coefficient of the denominator. If the degree on top is larger, there's no horizontal asymptote. You do need to recognize this, but no graphs like this. In other words, we talked about these things called slant asymptotes you don't have to do in this class, and you don't. But you do need to recognize when we don't have a horizontal asymptote. But you don't need to draw that one. But make sure you can recognize when there is no horizontal asymptote because the degree on top is larger. Recognize this. What's that thing they said in Mad Max Fury Road right before they would die? Was it remember me or remember this? Witness me. All right, x-intercepts in Math 121 are always found by finding the real zeros of the numerator and writing them as x-intercepts. So you find the real numbers that make the top equal to 0, and you turn them into ordered pairs. The number, comma, 0. That's how you find an x-intercept. That's it. If no real values cause the numerator equal to 0, then there are no x-intercepts. Did that ever happen in this class, no x-intercepts?
Yes.
Yeah, this can happen, so watch out for this. This can happen. We saw several examples with no x-intercepts at all. Y-intercept. If 0 was not removed from the domain, in other words, if you did not have to kick out 0, plug in 0 for every x and determine the result. That will give you your y-intercept. If 0 was removed from the domain, for instance, if you did something like this, if when you wrote your domain, you were like this, negative infinity to negative 4 to 0, 0 to infinity, this would have no y-intercept because you kicked 0 out. What would cause this to happen? This would happen if you had a denominator like this. This is the kind of denominator that would give you that domain because you'd have to kick out 0 and negative 4. Okay. So if this stuff looked kind of different to you and unusual, make sure you look over that again before the test because rational functions are an important part of this test. We did them right near the end, and that means sometimes people either didn't have enough time to absorb them or they thought since they just studied them they don't need to look at them again, but please make sure you look at them again because they are tricky. And as you can see, if you know these techniques, a lot of these things are not that hard to do as long as you remember how to do it. That's the big thing. I think people leave these blank on the test because they're like, I don't remember how to do that. And that happens, unfortunately. All right. All right, everyone, we're going to pretend to take a test. So put away your notes, put away your book. You can have some scratch paper out. You can have your calculator out. Remember, though, this is not collected or graded, everyone, so don't freak out. We're not taking a test right now. Rachel, will you pass some of these out for me? All right, everyone, so while you're getting your test, listen to this. This is a pre-test. I am not allowed to give tests, pre-test, practice tests that look exactly like your real test. So this is not exactly what your real test looks like. This does not have every concept from your exam. So if this is the only thing you study, you will be missing things that are on the test. So you should study some other stuff. This, however, will remind you of some difficult concepts. It does have some questions on it that are very similar to exam questions, even though it doesn't look exactly like your exam. It is an important part of your studying, and it's yours to keep. It's not collected or graded. There is a blank version and a complete answer key posted on D2L. So remember a couple things. First of all, I might not give you enough time to finish this. Don't worry about that. If you didn't finish it, you can work on finishing it later. Secondly, I'm going to go over some of these problems, but it's not just about me showing you the answers because the answer key is posted, so you can get the answers if you want. Those are easy to find online. I want to make sure you understand how I get the answers. So if you do have a question while I'm doing this, please let me know. Because as I said, it doesn't do any good to copy all of what I'm going to do here down because the answer key is available online. So this is to make sure we understand what's happening. I obviously don't have time to go over every single problem, but I'm just going to do a few of them. So I'm going to jump in with problem number 2 because we spent a lot of time on quadratics. And you have to know how to give a lot of information about quadratics. So first of all, what's the domain of every single quadratic? Negative infinity to infinity. And whether or not you have this form or the other form of quadratic, you look at the number in front of everything and that tells you whether it opens up or down. So since this one has a -3, what does this one do? Open up or down?
Down.
Down, yep, because of that negative in front of the 3 right there. The vertex here is a little bit of a challenge because you do have to use the formula. So what we have to do is we have to do the -b over 2a formula. That is a formula you're going to want to know. -b over 2a. In this case, that's going to be -18 all over 2 times -3. -18 divided by -6 is 3. Is that my vertex? No, because the vertex is an ordered pair. So in order to finish the vertex, what you have to do is you have to plug 3 back into the original function and crunch out a number. In this case, you will get a 6, so the vertex is 3, 6. And that's how we find the vertex. It's important to remember that once you find the vertex, you do get the axis of symmetry for free. You just need to remember what it is. It's a vertical line. It's not an asymptote, but it is a vertical line. And it's written as x equals 3. Same as the x value of the vertex. Now, once you know that your parabola opens in the direction it opens, in this case down, And once you know your vertex, which in this case is 3, 6, that is enough to get the range. Because these things either go up forever or down forever. Which one does this do? It goes down forever. That's why the range is negative infinity, and it goes all the way up to the vertex. But when we're talking about range, we're talking about y values. So what's that y value it gets to? 6. And we put a hard bracket there. Don't blow the y-intercept. When the equation is written in this form, the y-intercept is possibly the easiest thing to write. Because it is an ordered pair. It does start with 0, but what does it end with? Negative 21, the number at the end, because everything else would go to 0. So once again, this is posted online, everyone. You can go on here after class and find all these answers on there. So it doesn't do any good to see the answers if you don't understand where they came from. So please stop me if you see something up here and you're like, I see that that's the answer, Steve. I don't know how you got it. All right, we're going to complete the square now. Are you going to have to complete the square on the test? Yes, you are. And to complete the square, the first thing we do will be to set that equation equal to 0. The next two steps you can actually do in either order. What we have to do is we have to move the constant over the other side, and we have to divide by negative 3. It really doesn't matter what order you do those two things. I always move the constant first, just because I think it's nice to have kind of your own way of doing it, and so I always do that so I don't forget to do it, and then I divide by negative 3. Can't complete the square unless we have just an x squared with a 1 in front of it. Be careful of all your negative signs in there. There's a lot of negative signs running around on this one. So after you move the negative 21 over by adding 21 to both sides, and after you divide everything by negative 3, you should have x squared minus 6x equals negative 7. Now you don't apply the square root property yet. This is when we take that special number, cut it in half, and square it. What's the number I write off to one side here? Negative 6. I cut it in half. Negative 3. I square it. 9. Both the 9 and the negative 3 are of interest to me. The 9 is the number I add to both sides of the equation. But it's the negative 3 that tells me how to factor the left-hand side. That's why it's called completing the square, everyone, because you make it so the left side is a perfect square. You apply the square root property, don't forget your plus minus. This one's nice. We don't have to simplify that square root at all, just a square root of 2. Add 3 to both sides. I have no problem if you use a plus minus. Just be aware that that is 2 answers. So our zeros are 3 plus square root of 2 and 3 minus square root of 2, which are real numbers, everyone. They're irrational, but they are real because they don't have an I in them. They don't have a square root of a negative. And that is how we complete the square. If this right here was a mystery to you, please remember that there's a worksheet that's got a bunch of practice problems on it, and there's also videos on how to do this that you can watch on YouTube. All right. Story problems tend to freak people out sometimes, but I do want to remind you that story problems are usually asking you something you already know how to do. You just need to figure out what it's asking you to do. This one gives you the function, negative 16t squared plus 192t. And then the 4 questions here are actually asking this. The first one is just asking you to plug a 1 into that function. The second one is asking you to plug a 2 into that function. The third one, part C, is asking you to find the first value of the vertex. And then the last part is asking you to plug that value back into the function. So I'm not saying this is easy, I can't believe you didn't get this. What I'm saying is, remember, a story problem is usually asking you to do something you know how to do. Do we know how to plug numbers into equations? Yeah. Do we know how to find a vertex? Yeah. We can do all that stuff, we just need to make sure we know that's what it's asking us to do. So if you plug a 1 into the function, you will get 176. If you plug a 2 into the function, you will get 320. If you do negative b over 2a, you're gonna have negative 192 over 2 times negative 16. You crunch that out either in your head or on a calculator, you'll get 6. That's how long it takes for it to reach its maximum height. You plug that into the function, and you'll get 576. Now there's only one problem with my answers up here. Does anyone know what's wrong with my answers?
The vertex, we have 2 answers.
Well, the vertex is actually broken up. It's supposed to be broken up into 2. So the vertex is 6, 576. But this is specifically asking for 2 answers, so that's okay.
You're missing units.
We're missing units. This doesn't tell us anything. How high is the rocket 1 second after its launch? Oh, it's up there. It's at 176. 176 what? Well, it tells you right in the question that our units are both feet and seconds. So make sure you answer with the right units. If it says, how high is the rocket? What is that? Feet. How high is the rocket? Feet. How long does it take? Seconds. What is the maximum height? Feet. Don't forget your units. Question?
No, never mind.
You cool?
Yeah, I figured it out.
Okay. Anyone else? Questions? Don't let the story problem spook you. Just look at it carefully and say, he's asking me to do something I know how to do. I just need to figure out what he's asking. You gonna have to graph a parabola on the test? Yeah, you are. We better make sure we can do this. Oh, I like this form. I really like this form because the vertex is really quick. I just got to remember to be careful because the vertex is not 3, negative 4. What is it?
Negative 3,
Negative 4. I got to remember to switch that x value. Okay, negative 3, negative 4. And my vertex right there. Let's see here.
The x of symmetry.
What's that?
The x.
Oh yeah, we can put the axis of symmetry in there. Let's drop that in there. That will help us. Yeah, because we got to make sure it's symmetric over this. So I'll label that as x equals negative 3. Good, that's a good idea. Let's do our y-intercept next. I don't feel like doing my x-intercepts yet. To get my y-intercept, I plug a 0 in here, but please don't rush this because this is going to give you 5. And you got to be careful to make sure you crunch that out. So if I get 5, I get my y-intercept right up here at 0, 5. Now, do I get another point for free?
Yes.
Yeah, these things are symmetric over the axis of symmetry. That was a good idea to draw that. So I get another point on this side right here. All right, I can see this thing has x-intercepts. I just need to find it. Now, check this out, everyone. I take this x plus 3 squared minus 4 equals 0. Watch how quickly I'm going to find the x-intercepts. This is awesome. I'm going to add 4 to both sides. I'm going to apply the square root property. And I'm going to subtract 3 from both sides. Negative 3 plus 2, negative 3 minus 2. I just need to make sure I get the numbers for that. What would that be? Negative 3 minus 2 would be negative 5, 0. And negative 3 plus 2 would be negative 1, 0. And if I think I made a mistake, I'm going to find out soon enough because let's see where these are. Negative 1 and negative 5. Do those look like they could be the right x-intercepts? I'd say so. They're symmetric. Okay? If you want, you didn't have to, but if you wanted to, you could have plugged both a negative 2 and a negative 4 into the function, and both of these would have given you negative 3. The only reason you might have done that is if you said, I want a couple extra points. But we've got enough really already. Okay. Why does it say be neat? Because I don't want you to do this. I do not want you to do this. Actually, that came out okay for how fast I did it, but no. Take a little bit of time. Make it nice and rounded down here. Make sure you hit your points. And make sure you have arrows to show it keeps going. All right, does that look okay to everyone? Once again, it's not about seeing the answer, it's about knowing how I got the answer. Everyone can see the answer later. Let's sketch a polynomial. Let's sketch a polynomial. All right, so I don't know where you want to start. Let's start with writing down the factors or the zeros. I guess, I don't know, we can start, let's start with the factors. So I'll go x minus 4, x minus 2, x minus 5. Ah, that's pretty good. I'm very good at that. Is my graph going to work out okay? No, what happened? I forgot one, and I forgot the one that's the easiest one to forget because it doesn't look like a regular factor. Yeah, these look like factors. That one doesn't look as much like a factor, but it's just as important, the x in front. So my zeros are 4, 0, 2, and 5, and my x-intercepts are 4, 0, 0, 0, 2, 0, 5, 0. Sorry, I messed up one of these. What did I mess up? That should be x plus 4. I'm sorry. Everyone, I wrote it wrong. That should be x plus 4. That's another reason my graph wasn't going to look right. Yeah, x plus 4, x minus 2, x minus 5, giving me negative 4, 0, 0, 0, 2, 0, and 5, 0. Holding the answer key in my hand, and I still make a mistake. All right, multiplicity. Look at the power on the factor. What was the power on x plus 4? 2. What was the power on x? 3. What was the power on x minus 2? 2. What's the power on x minus 5, even though it's invisible? 1. If I add up all these multiplicities, what will I get? I'll get 8. And what does that 8 mean?
The degree.
That's right. The degree is 8. Very good. Degree is 8. And the leading coefficient is what, everyone? What's the number? Not the x's, but the number in front of everything. Negative 2. Think, everyone, even degree. It does the same thing on both sides, right? Negative leading coefficient. What does it do on both sides? It goes down. Good. I guess I should write what's going to happen at each one of these. What does it mean if the multiplicity is even? What does that mean? That means a bounce. If the multiplicity is even, you're going to bounce. What does it mean if the multiplicity is exactly 1? It's just 1. It's just going to cross. And what if it's some odd number bigger than 1, like 3 or 5 or 7? It's going to do the cross and flatten thing. All right. Does anyone see any mysteries or secrets up there? So my x-intercepts, I'll label those first here. They're going to be negative 4, 0, 0 here, 2, 3, 4, 5. I'm going to write little notes to myself that I'm going to bounce at this one. I'm going to cross and flatten at this one. I'm going to bounce at this one. I'm going to cross at that one. And I'm going to make another little note for myself that my end behavior is going to be down on both sides. This next part is very difficult to do if you don't practice it. Is there a worksheet where you can practice this if you haven't already? Yeah, you can practice this. All right, here we go. Coming at the first one, nice smooth bounce. Coming at the second one, nice smooth cross and flatten. Next one, we have a bounce. And last one, we have a cross. The y-axis is not labeled. It is arbitrary how low you want to go down or how high you want to go with the tops of your hills. Just make sure you keep it smooth. Oh, I like that. Keep it smooth. All right. Doesn't do any good to look at the answer if you don't understand where it came from. There are mysteries or secrets on this problem I can help anyone with? Anything haunted about this? Either of these?
Not with the problem specifically, but when it's a odd degree negative coefficient, or the thingy right at the beginning, yeah, does that start at the bottom and then end up on the right?
Odd degree, negative leading coefficient would look like that.
Okay, so odd degree.
That's mean the range.
The way I remember it is this is how I remember it. I remember f of x equals x cubed, which is odd and positive, looks like this. So therefore odd and negative is going to be the opposite of that.
All right, cool.
That's how I remember it. Does that answer your question? You cool? Okay. You sure? You didn't seem so sure. Just want to make sure you're cool. All right. Now we know that it is possible to do some guess and check. But we also know that's a more practical homework exercise and test exercise because none of us on a test feel like we have the time to start guessing and checking all the factors of 105, both positive and negative. So that is why we are very happy to see that there's a hint on this one that tells us -3 is a 0 and x minus 5 is a factor. Just remember, when I give you the 0, that's what you do the synthetic division with. When I give you the factor, that's when you got to switch the sign before you do the synthetic division. Does it matter which order you do the synthetic division with these two? It does not. You can do it in either order. Now, your middle step's going to look different depending on which one you do first, but you're all going to end up with the same quadratic at the end. So I'll do 5 first. I will do 5 first. And because I was promised on this problem that I was given a factor and a 0, I know that I should get a remainder of 0. If I don't, that means I made a mistake. 1, 5, 9, 45, 11, 55, -21, -105. It worked. Now, of course, if you did it with -3, you're not going to get this answer. But as I said, after you do them both, you will get to the same place. Please remember, the original up here was degree 4. That means this is a degree 3, and this right here is the remainder. So now, when I do my -3, 1, 9, 11, -21, 1, -3, 6, -18, -7, 21, 0. And this will be a degree 2. And no matter which order you did them in, everyone, no matter which order you did those two in, you will have the x plus 3, the x minus 5, and everyone should get it down to x squared plus 6x minus 7. It should not matter what order you divide them. You'll get x squared plus 6x minus 7. I did say on the test you're going to have to know how to do some light factoring, and this is what I consider light factoring. Figuring out the two numbers that multiply to -7 and add to positive 6. So that's going to be x plus 7 and x minus 1. Don't forget the number itself and 1. So what are my factors in any order? What are they?
X plus 3, x minus 5, x minus 1, and x plus 7.
What are my zeros then? -3, 5,
1, and -7.
good. And my x-intercepts? They're the same thing as the zeros, just written as ordered pairs. -3, 0, 5, 0, 1, 0, -7, 0. Just making sure that we can go between factors, zeros, and x-intercepts. And that's it. That's done. This problem was not a matter of doing guess and check. It was a matter of knowing how to do your synthetic division to factor a polynomial. I'm not going to tell you this is the easiest problem ever, but I will tell you there was absolutely no guesswork involved here, with the possible exception of maybe you did a little guess and check to factor the quadratic at the end. By the way, if you're terrible at factoring, could you always use complete the square or the quadratic formula to have found the last two zeros? Yeah, you could have. Question?
So for the x squared plus 6x minus 7, could you substitute that with the above division, the 9x, the 1, 9, 11, and...
Okay. Did anyone try to do that problem right there? It's okay if you did, you don't need to tell me. That's a very common mistake, just thinking this thing is all set to go, but it's not set to go. Because it's not in the right order. So this thing's got to be rewritten as 2x to the 5th minus 14x cubed plus 10x squared plus 13. Is that correct?
No.
Shoot.
You'd like to do.
We got to put some zeros in there to hold the places. So what we really have to do is we have to rewrite the polynomial as 2x to the 5th plus 0 minus 14x cubed plus 10x squared plus 0 plus 13. You got to put in a 0 to hold the x to the 4th spot and the x spot. So now it's going to be -3, 2, 0, -14, 10, 0, 13. Does that look okay? Does it say anywhere on this problem that x plus 3 is a factor? No, it just tells you to divide. Does that mean our remainder might not be 0? Yeah, it's not our fault we don't get 0. So 2, -6, -6, 18, 4, -12, -2, 6, 6, -18, -5. Okay, so we got to make sure it's all set up. Then we can do our synthetic division. What do we have here? This is a degree 5. So my answer is degree 4, and this is my remainder. Well, if that's my remainder, I can actually do this one right here at the bottom right away. The remainder theorem says that if you plug a -3 in the function, you're going to get the same thing as the remainder. So that is the remainder theorem. Now, it was a while ago, and I know it was a while ago, but did we discuss that there were different ways you might have to enter an answer for one of these?
Yeah.
Yeah, so the middle one is actually, I think, the easier one to do first, because that's just going to be 2x to the 4th minus 6x cubed plus 4x squared minus 2x plus 6. And you have choices here. You can either do plus -5 over x plus 3, or you could do -5 over x plus 3. It doesn't matter which one of those you do, as long as you got the minus in there somewhere. This was the one where you did divisor times quotient plus remainder. So this is the one that would be x plus 3 times 2x to the 4th minus 6x to the 3rd plus 4x squared minus 2x plus 6, and then -5 on the outside. On that first one, are the parentheses important?
Yeah.
Yeah, absolutely. Absolutely. Otherwise, I wouldn't have put them in there. Okay. Class, as far as number 1, check your answers on D2L. Make sure you did that one right. Make sure you found the zeros properly. Those are all a bunch of different quadratics, and they all have slightly different ways of finding their zeros. So make sure you take a look at that one. I don't have the time to do it in class. Number 5, which I also skipped, make sure that you're doing the right thing for degree. Factored, remember, when it's factored, you degree is you add the powers. If it's unfactored, the degree is the highest power. So it's different how you define the degrees, whether it's factored or unfactored. And just so you know, everyone, h of x, the y-intercept, involves some number crunching. So if you think you're doing something wrong when you're finding the y-intercept for h of x, no, you actually have to put a 0 to all those factors and crunch out a number. That one's the one that takes the longest to find the y-intercept. Okay, and remember, there's a chart in the notes to help with end behavior. I think it's better just to be able to figure it out by looking at the degree and the leading coefficient, but if you need the chart to help you, you can look at the chart. And then finally, Number 9, use the rules I gave you in the notes. If you did not get a chance to do it yet, try to do number 9 without looking at any notes first, and then go back and look at the notes. But that is a very, very good drill for domain, vertical asymptote, horizontal asymptote, x-intercept, and y-intercepts. Because, just so you know, even though you only graph one rational function on exam, there are several questions, shorter questions, about rational functions. So in other words, there might be one where I just give you a rational function, I don't ask you to graph it, but I say, just give me the vertical asymptotes. So everyone's clear on that? You might just have to do some quick things also. We're out of time, everyone. We're going to take a test next class. So please come, be on time,